All right, my friends, for problem 6 here, given this rectangular equation, graphing it on the rectangular plane here, I'm going to go ahead and complete this square with it. I am expecting a hyperbola just because you have the degree of x and y are both 2, and one's positive and one's negative. So it is kind of nice going in to know what to expect. I'm going to factor the 3 out of the x terms. And then I'm going to leave the y squared the way it is and then subtract the 9 over. Next, the magic ingredient for the x terms here would be 4. Careful, you actually just added 3 times 4, so you'd have to add 12 onto the other side to rebalance. So now factoring this piece, you get something like this. Now dividing by 3 to write it in standard form. These 3's will cancel. You'd have x minus 2 quantity squared over 1 squared, which you wouldn't especially have to write it, but couldn't hurt. And then y squared over, and 3 is square root 3 squared, like so. So graphing it, the center would be shifted to the right 2. The boundary box underneath x, you see 1 squared, so you'll go in the x direction, 1 unit in each way from the center. Underneath y, you see square root 3 squared. Well, square root 3 is about 1.7, so you need to go from your center up 1.7 and down 1.7. There we go. From there, you could draw your asymptotes in. It must go through the center and the 2 opposite corners of the boundary box there. Okay. Next, since your x term is positive, your hyperbola would open horizontally. So the point 3, 0 would be one of the vertices. And the point 1, 0 would be another vertex. All right, my friends, and it should go without explaining after how much we've been through together this year, that if you don't have any of this completing this square work, then you would not get any credit. You know, especially, you know, with Desmos out there and all that garbage that you could use to just punch things in, you do have some burden of proof put upon you to explain that you do know what you're doing here. So hopefully that makes sense. Okay. So with that said, assuming that you have work, let's make sure that you get some credit as we go, okay? So having a graph that is a hyperbola that opens horizontally like this, that's worth 1 point. Having the center of the, actually no, let me not word that. Okay, having the boundary box be 2 units by 2 square root 3 units, a 2 by 2 square root 3 boundary box. That's worth 1 point. Having your center at 2, 0, worth 1 point. Let's see, what was the next thing? Oh, having the vertices at 1, 0 and 3, 0, worth 1 point. And then the last thing is this asymptotic behavior at all 4 corners, where your graph doesn't all of a sudden like start going away from the asymptote. It gets closer and closer and closer. So the point is a hyperbola, as it goes out, it starts thinking it's just this line graph. So we're going to call that asymptotic behavior. And altogether it's worth 1 point, so it's like a 1/4 point per little piece over here. And that's your 5 points. All right, did I give myself any room for part B? I think I'm okay. Okay, Add the coordinates of the foci. Okay, so you need the Pythagorean identity for hyperbolas, so that's c squared equals a squared plus b squared. Let's see, a and b are 1 and square root 3. So 1 squared is 1, square root 3 squared is 3. So your c values would be plus or minus 2. If you just wrote c equals 2, I'll accept that as well, because the way we interpret c as a distance, it kind of makes sense to have it be positive. Anyway, so then from there, you need to know that that means the distance from your center to your focus. So your center's here, so just go 2 units out in this way. You'd find out you have one focus at 4, 0, and then from the center, 2 units the other way, and you find out you have focus at 0, 0. There you go. Okay, so this was worth 4 points, so we'll give you 2 points. Oops, use pen red, I guess. Okay, 2 points for showing the work and getting a C value of at least 2, if not plus or minus 2. And then you get 1 point for labeling the point 4, 0, and 1 point for labeling the point 0, 0, coordinates and all. And that's your 4 points there. All right, for part C, write the equations of the asymptotes here. So you can use point slope. Both lines go through the point 2, 0. So I'm just going to point out. You got both lines hit that point. And then the slopes, what would the slope of this line be? Well, you go up square root 3 over 1. So the slope would be square root 3. What would the slope of this line be? Well, you went down square root 3 over 1. So its slope would be negative square root 3. So the slopes would be plus or minus square root 3. Now use point slope. So we'd have y minus 0, or just y, equals your slopes times x minus 2. So anything equivalent to that. Y minus 0, of course, is just y. Like so. So either of these would be fine. If you chose to distribute the square root 3 in, that's where things can get a little complicated. You'd have to do it in 2 cases, one for positive square root 3 and one for negative square root 3. But if you decided to, you'd get y equals square root 3x minus 2 square root 3. And then with using the negative square root 3, you get y equals negative square root 3x plus 2 square root 3, right, from distributing that in, okay? So it's only worth 2 points. So let's just say 1 point for having the slopes, and then the other point is for having the equation perfect. So in point slope, that would look like this, and then in y equals mx plus b form, you would need both of these for that point right there. So hopefully that makes sense. There we go.